This is video number 2 for sections 8.3 and 8.4, adding and subtracting rational expressions. Remember, I can't subtract fractions unless the denominators match. These two denominators don't match, so I'm going to have to find an LCD. How do we do that? Well, we learned in the last video that finding an LCD starts with factoring your denominators. The numerators are not involved at all, just the denominators. Before, we were factoring numbers. We were just using prime factors. Now we're factoring expressions, and so I need to use my overall factoring strategy. For this first one, I check for a GCF. I don't see one. I'm counting 3 terms. 3 terms makes me think, okay, this was somebody's FOIL problem. I could go off to the side and use the Xbox method, but these numbers are so tiny, I'm pretty confident I can just work it out using trial and error. It's got to be x times x at the front in order to make x squared. I go to the back. The only way I could make a 2 in the back would be to use a 2 times 1. If I can just figure out what signs to put in here, I think I'm all good. I need to make a minus 1x in the middle. Let's see, I have a 2x as the inner, I have a 1x at the outer. I think if I go negative 2 and then plus 1, I've got it. Negative 2x and positive 1x makes negative 1x. Okay, so I have factored the first denominator. Then I go and I factor the second denominator. Now that one has a GCF. I can pull out a 2, leaving me with x plus 1. I always fully factor, but x plus 1 does not keep going, and so I'm finished. I am now looking for each fraction at the building blocks of the denominators. And remember, we said that the LCD is going to be found by multiplying some of those building blocks together. How do we decide which ones to take? It's all about satisfying the different lists. This time I have 3 different kinds of factors. I have 2's, I have x minus 2's, and I have x plus 1's. Well, how many 2's do I need to take for my LCD? I only need to take 1. The first list doesn't even have any 2's, but the second list needs a 2. So I'll need to take that 2 to satisfy the second list. How about x minus 2's? Only the first list has an x minus 2. It's only got 1, so I'm just going to take 1. The second list doesn't need it, but remember, it's the pickier list that I look at. How about x plus 1? Well, this guy needs 1, this guy needs 1. Great. As long as I take 1 then, each list is satisfied. Would I need to take 2 x plus 1's? Of course not. This guy doesn't need 2 x plus 1's. This guy doesn't need 2 x plus 1's. If you want to relate this to the grocery store problem, this would be like the first list saying a loaf of bread and a gallon of milk, and the second list saying a dozen eggs and a gallon of milk. What are you going to get? Well, of course you're going to get the gallon of milk, but just in case, you're also going to pick up that loaf of bread and that dozen eggs. Okay, in any case, the LCD is what we've got right here. And I guess one difference in these problems compared to the plain old fraction problems is I'm not going to multiply this out. You know, when we did it before, we multiplied the numbers and we got 18. I'm going to leave it in this factored format because that's going to be easier for me to use as this problem goes along. Let's go back to our original fractions here. What we are saying is that we need to change these fractions from the denominators they used to have into this new LCD. When I factor the denominators, by the way, I usually cross off the old one because I really don't need to look at that anymore. I can just concentrate on these new factored denominators. In fact, let me rewrite the two fractions clearly with these factored denominators in place. And then what I need to do now is create 2 equivalent fractions that have the denominator that I wanted, namely this LCD. I've put the new LCD at the bottom here. How do I actually make the change? This is so important. I look at what I used to have, I look at what I want, Remember, I can multiply this denominator by anything I want. Well, the only thing missing from it is the 2, and I can do that as long as I come along here and multiply that guy by 2 as well. 2 times 4 is going to give me 8 as my new numerator. How about the second fraction? I'm just comparing what I used to have to what I want, and I can see that I have most of the pieces. I'm just missing the x minus 2. Well, I can tack it down there as long as I also put it up top. Just like I multiplied 2 times 4 to get 8, now I'm going to multiply 3 times x minus 2. Go ahead and multiply it out. Parentheses on the top are not helpful to you. They're fine on the bottom because nothing happens to the bottom. It just stays the same. But the top parts actually get combined. So you want to get rid of those parentheses as fast as you can. Okay, remember, you're just about at the end here. There's not much left to do. Don't start thinking about cross-canceling or anything strange like that. You have made these denominators match so that now you can actually do the subtracting. Now, the last problem we had with the numbers, we just did that in our head. What's probably a good idea here is to write down what it is we want to do. I want to do 8 minus that numerator. Now, be careful, because if you want to subtract that whole thing, and that's what you need to do, you're going to need a parenthesis there to show that that entire thing is being subtracted. Watch out for that. And then what about the bottom? Well, the bottom just stays the same. All right, let's go ahead and carry out this subtraction. We haven't actually done anything yet. We've just written it down. I suppose the first thing to do would be to clear the parentheses. Remember, parentheses on the top are completely unhelpful here. I have like a minus 1 in front that I need to distribute. So that's going to become 8 minus 3x plus 6 after I distribute that minus. Again, the bottom is unchanged. And now I have some like terms up on the top there. 8 plus 6 is 14 minus 3x. Again, bottom is unchanged. Now, at the very end, you can ask yourself, can I reduce? Don't ask that question until you have fully worked out that top problem. Your bottom, of course, has stayed the same. Now you can try to reduce. Well, how do you do that? Well, we learned how to do that at the beginning of Chapter 8. You can only reduce these things if you first factor everybody. Well, the bottom is already factored. That's why we left it that way, because it's helpful to have it factored at the end here. So that's set. The top is certainly not factored. That's not a giant multiplication problem, so I'll need to factor it. How would I do that? Step 1, pull out the GCF. I don't see a GCF. Step 2, count the terms. I've got 2 terms. Is this a difference of squares or something like that? No, it's not. This top thing doesn't factor. Well, if it doesn't factor and you don't see a copy of it down on the bottom, then you're done. There is not a single other thing you can do to this. This is the final answer to the problem. Okay, let's try this second example now. Similar idea. We've got 2 rational expressions, 2 fractions that we're trying to add. The denominators don't match, so I'm going to have to find an LCD. I do that by thinking in terms of factors. Let's see. This first denominator, I have a GCF, an x that pulls out, leaving me with 2 minus x. The second one, I don't have a GCF. I do have 2 terms. Oh, I see. It's a difference of squares. So this is going to factor a plus b and a minus b. The b would be 2. Once everything is factored, then I can come and write down my LCD. This is where I think about the lists and satisfying each list. Now, this particular problem has a twist, and that's why I picked it. You might be looking at this saying, oh, wow, now I've got 4 different types of factors here. X, 2 minus x, x plus 2, x minus 2. I suppose that's technically true. However, you don't have to work with all 4. Hopefully you realize that 2 of these are very, very close to each other, just kind of backwards. I'm talking about the 2 minus x and the x minus 2. When you have that with subtraction, what you want to do is you want to fix the one that looks backwards so that the 2 pieces match. Okay, this is clearly the one that looks backwards, the 2 minus x. How would I fix it? The answer is factor out, in addition to what you already factored out, factor out a negative to change all the signs. In fact, really, I should have done that at the very, very start. Look at this thing that we started with here. This is really written backwards anyway. We always put our higher exponents at the front. So what I probably should have done with this at the very start is written it around the other way, and that would have reminded me that when the lead coefficient is negative, I'm supposed to pull that out in addition to the rest of the GCF. And see, when I do that, I'm going to be left with a positive x here and a minus 2 here. This would really be the better factored form of the original denominator. Now when I go over here to do my grocery list, I only have 3 items to worry about. I have the x minus 2, I have the x plus 2, and I have the x. Now what about that minus sign that we just pulled out? Since I've gotten a little messy here, let me rewrite the problem to show what we have right now. I really don't want that negative sign down there. It's going to make my LCD kind of difficult. Well, you might remember with fractions, if you have a fraction like this with a negative sign on the bottom, there's a couple other places you can put that negative sign. You can move it over here to the side, or you can move it up to the top. Well, remember, in a problem like this, the tops are the parts that actually get combined. That's where I need to take this negative. I'm going to rip it off, and I'm going to assign it up here to the top. Now, it does impact the entire top, so I'll put a parentheses there to show that. That means the new numerator here is now negative 2x plus 4. I distributed that minus into both parts. And my denominator is now fixed. It's just got that positive x and the x minus 2. Let me rewrite the other one as well. My LCD is now very easy. I'm going to have to take an x to satisfy the first list. I'm going to have to take 1x minus 2. Nobody has more than 1, x minus 2. And I'm going to have to take 1x plus 2 to satisfy that second list. I'm not taking 2 of anything because no list has 2 of anything. There's my LCD, and what I need to do now is change the 2 fractions I have so that the denominators match this LCD. There's a lot of writing with these problems. Don't shortchange that so that you don't make any mistakes. This next step is so important. This is where I look at what I had and I look and see what I want. Who's missing? Well, from this guy, it's the x plus 2. No problem. I can tack that on down there as long as I also fix the top. From the second guy, who's missing? Just the x. Well, I can multiply that there as long as I also multiply the top. Notice that you're multiplying the entire tops. That's why I'm putting them in parentheses. Parentheses on the tops, totally unhelpful. So when I go to my next step here, I'm going to have to FOIL this out. It's a big mess, but that's what I need to do. I need to FOIL it out. That's going to give me negative 2x squared. Outer would be plus 4x. Inner is minus 4x. And last would be 8. The other guy is not quite so bad. It's not a FOIL, it's just a distribute. So 2x times x, 2x squared, and 4 times x. We've reached the point now where the denominators match, so we can go ahead and just add. Just do it. Adding's even easier than subtracting. I think we can just do it as we go here. Just add up all the terms on the top. A lot of them cancel out. Negative 2x squared plus 2x squared. Goodbye. Plus 4x minus 4x. Goodbye. The only thing I have left is 8 plus 4x. I'll write it in the correct usual order. 4x plus 8 for the top, and the bottom stays the same. Remember, only after you've completely added the tops do you think about possibly reducing. Can I reduce this? I don't know, because I have to check to see if I can factor the pieces. The bottom is already factored. The top, I see I have a GCF, so I can factor that. And after I copy down the bottom here, I think you can see that this time I do have a common factor on the top and on the bottom. And so I get rid of those. The final answer is what's left. We like to keep our answer in factored form, and so here would be the final answer to the problem.